Hello math lovers, and welcome to another video of our channel of the series Math Olympiad Training Problems of 2025. Today we have selected a very classical inequality, which of course many of you might have seen in different Olympiads or in different books for Olympiad training. We decided to bring it forward to you as I said, is a very classical inequality which is worth taking a look to. The request of the problem is like this. Prove that for every natural number n greater than 1, we have that 1 divided by 4 plus 1 divided by 9 plus 1 divided by 16 up to 1 divided by n squared is smaller than 1. So, in other words, the sum of inverse of squares of natural numbers is smaller than 1. If you have any solution, please write it down in the comments. If not, let's take a look at one form of solution together, because there are many solutions you can write down for this problem. So, as we said, we are asked to prove that for every natural number n greater than 1, the following inequality holds. So, the sum of inverse of perfect squares is smaller than 1. Now, in order to solve this problem, we start, as always, by making some simple observation. The terms of this left-hand side of the inequality can be expressed in another way. So 1 divided by 4 is equal to 1 divided by 2 times 2, but this expression over here, it is smaller than 1 divided by 1 times 2, because 2 is greater than 1. In the similar way, we can say that 1 divided by 9, it is equal to 1 divided by 3 times 3, which is smaller than 1 divided by 2 times 3, because 3 is greater than 2. And this can be done up to the number n, and arriving to number n, we can write that 1 divided by n squared is equal to 1 divided by n times n, which is smaller than 1 divided by n minus 1 times n, because n is greater than n minus 1. Now, by adding some side by side these inequalities of the system that we just saw, we will have that the sum of inverse of all perfect squares from 2 to n squared is smaller than 1 divided by 1 times 2 plus 1 divided by 2 times 3 plus 1 divided by 3 times 4 up to 1 divided by n minus n times n. Now, for this new form, for this true inequality over here that we got by the system of inequalities that we wrote down, we can further elaborate the right-hand side of this inequality. And we will get that the right-hand side will be transformed to 1 divided by 1 times 2 is equal to 1 divided by 1 minus 1 divided by 2, while 1 divided by 2 times 3 is equal to 1 divided by 2 minus 1 divided by 3, and so on, up to the expression 1 divided by n minus 1 times n is equal to 1 divided by n minus 1 minus 1 divided by n. But we see that all these expressions over here simplify with each other, and then the only two terms which remain are 1 minus 1 divided by n. But of course we know that this expression over here, it is smaller than 1, because 1 divided by n is a positive number, even if it might be a very small value. So the sum of inverse of perfect square, it is smaller than this expression, but this expression itself, we just proved that it's smaller than 1. This means that the sum of inverse of perfect squares is smaller than 1, which is what we wanted to prove in this problem. So if you like this solution, please support our channel, and hope to see you on our next videos. Thank you and have a nice day.